Hello everybody and welcome back to Calculus 1 with Professor Val Lockman at Frederick Community College. In this video I will cover the quotient rule for computing derivatives. So last time we've done the product rule, and in this case we're going to talk about what to do when you ask to compute a derivative of a quotient of two functions. So here's your formula. It says that if f and g are differentiable at x and g is not equal to 0, because g is in the denominator, we compute the derivative the following way. It's f prime times g minus f times g prime divided by g squared. Okay, so a couple of things to mention here before we move on to actual examples. Okay, the order here matters. Order in the numerator matters. Okay, so when you do these computations, make sure that this is what you do: f prime times g minus f times g prime. Okay, so it's not g prime times f minus f prime times g. Okay, so that's one common mistake to avoid. Also, it's simply not f prime over g prime, right? G prime not squared. Okay, we need to remember the formula correctly. All right, let's go ahead and do problems. Okay, the first one says compute the derivative of the function x over x plus 1. So in this case, your f would be just x and g would be x plus 1. So we'll start with an example that's kind of simple. All right, f prime of x would be the first one prime times the second one minus the one on top times the one on the bottom prime all over x plus 1 squared. Okay, so just like with product rule for the first few examples, I recommend that you set it up like this, just like following the formula to a T. And then once you get enough practice, you can skip the steps. Okay, x prime, that's 1 times x plus 1 minus x times what? X plus 1 prime, that's also 1. On the bottom, we get here x plus 1 squared. You don't need to multiply this through. You can keep it in factored form. All right, so we get x plus 1 minus x over x plus 1 squared. So that simplifies to 1 over x plus 1 squared. Okay, that is the first example. Again, what have we done here? We just followed the formula very carefully, computed the derivative, simplified. If you can reduce things, go ahead and do that. In this case, we can't reduce anything. Okay, let's go ahead and take a look at an example that's a little bit more involved. What do we have here? All right, f of t is a quotient, 2e to the t divided by t squared minus 1. Okay. All right, let's see. So this would be f prime of t is equal to the top function prime times the bottom minus the top function times the bottom prime over the one on the bottom squared. Okay. Now we'll compute derivatives. 2e to the t prime, that's just 2e to the t, times t squared minus 1, that doesn't change, minus 2e to the t times what? The derivative of t squared minus 1. Oops, I made a typo here. This should be prime, not squared. Okay. So the derivative of t squared minus 1, that would be 2t over t squared minus 1 squared. Okay, so let's see. 2e to the t is a common factor, we can actually just factor it. And we get t squared minus 1 minus 2t over t squared minus 1 quantity squared. Sometimes when you can compute these derivatives, you could have common factors in numerator and denominator. I don't think that's the case in here, but always inspect these. See if there are common factors. And if there are, just reduce them. Okay? In this case, for this example, there are none. Okay? So that's it. This is how you would leave it. Just like that. That would be your derivative. Okay? All right, let's go ahead and take a look at an example that has a trinomial on top. Okay, how do we deal with that? The formula is the same. Now we just have a little bit more involved computations. Okay, so we have to be a little bit more careful. Okay, I want to compute f prime of y. What's my setup? The top function prime times the bottom minus the top function times the bottom prime. Divide everything by y minus 2 squared. Okay, so this example is just a little bit more involved. There's a little bit more algebra here, but the idea is exactly the same. The formula is the same as before. Okay, let's see. What's the top function? Prime. That's 3y squared minus 8y plus 1. Okay, remember the parentheses, they need to go around this quantity. Okay, y minus 2, that stays as is. Okay, minus, let's see what happens here. I'm going to rewrite this function. We don't do anything with it. Y minus 2 prime, that's 1. Divide by y minus 2 squared. Okay. All right. We need to multiply everything through, combine like terms, see if we can simplify this. Okay, what do we get here? So this is 3y cubed minus 8y squared plus y minus 6y squared plus 16y minus 2. Okay? And now we distribute the negative, so this is negative y cubed plus 4y squared minus y. Divide everything by y minus 2 squared. Okay, now we need to combine like terms. Okay, this one and this one, that gives us 2y cubed. Let's see the quadratic term. This one, and that one. Okay, negative 8 minus 6 plus 4. What is that? Negative 10, right? Okay. Linear terms. Y, negative y, and positive 16. So that's positive 16y, and we only have one constant, negative 2. Okay, divide everything by y minus 2 squared. Okay, well, we can factor out the 2 here. Cube minus, let's see, what is this? 5y squared plus 8y minus 1. Divide by y minus 2 squared. Okay, and you can see if y minus 2 goes into this cubic. It doesn't, but you can check to see if it's a factor. It's not a factor in this case. So that's it. You can't reduce it anymore, and this would be your answer. This is it. Okay. All right. So now let's go ahead and do a problem that comes up all the time. Equation of the tangent line to the given curve. All right. Now that we know how to compute a derivative with the quotient rule, it's a lot easier to solve these problems, right? You don't need to use the limits definition, okay? So how do we approach this problem? We have a curve, we have some rational function, a point on the curve, we want to find the equation of the tangent line. So we need slope and a point, right? That's what we need. Okay, well, let's find the point first. That's the easy part. Point. Okay, remember what this is. This is your x, right? So if x is equal to 3, what do we get? 3 plus 5, 3 minus 1, that's 8 over 2, so that's 4. So my point is 3, 4. Okay? Now I would like to find the slope of the tangent line at that point. Okay, so what do? We need to find the derivative. Y prime is equal to what? X plus 5 prime times x minus 1 minus x plus 5 times x minus 1 prime. Divide everything by x minus 1 squared. Okay. Let's see. X plus 5 prime, that's 1. X minus 1 prime, that's also 1. Divide by x minus 1 squared. Okay. All right, what do we get? X minus 1 minus x minus 5 over x minus 1 squared. So the derivative is negative 6 over x minus 1 squared. All right. Okay. We know the derivative for any point. Now we can evaluate it at 3. So y prime evaluated at 3 is negative 6 over 3 minus 1 squared. Okay, what do we get here? Negative 6 over what? 3 minus 1, that's 2 squared, that's 4. So the slope is negative 3 over 2. So we already know that if we graph this function in our point, the tangent will be negative, right? So the line will be going down to the right. We'll check that with Desmos. Okay, so now I'm going to put it all together. What is my equation of the line? So it's y minus what? What's my point? The point was 3, 4. So minus 4 is equal to the slope x minus 3. Okay? And what do we get? Negative 3 over 2x plus 9 over 2 plus 4. If I simplify this, my final equation should be y is equal to negative 3 over 2x plus 17 over 2. Okay, so I have a line with the negative slope, should be going down. Let's go ahead and check that. I'm going to go ahead and check that with Desmos. Okay, let's graph the line. The actual curve first. So y is equal to what? X plus 5 on top. Okay, divide by x minus 1. Okay. Our point was 3, 4. Now let's go ahead and label it, and there it is. Okay, and if we found the equation correctly, it should be tangent to the curve at that point. So the equation was y is equal to negative 1.5, right? 1.5x, okay, plus 17 over 2, right? 17 divided by 2. And there it is. Okay? Perfectly tangent to this point. Exactly one point of intersection. Alright? So let's say you are submitting this as your homework assignment. Okay, and I ask you to make a sketch. Then you check it with your Desmos, and then just make a quick sketch. So what would you have here? So here's your plane. All right, let's make the line on the curve itself. So here's my function y. So let's say this is y is equal to x plus 5 over x minus 1. My point somewhere here. Okay, so this point is 3, 4. And the line, let's make it a different color. Okay, there we go. That's the sketch that I would expect to see. So the line is y is equal to negative 3 over 2x plus 17 over 2. All right. Okay, so let's go back all the way up to the formula. Okay, there it is. That's something that you need to remember. The order matters. One of the other common mistake is putting a positive here. Now, this should be negative. Okay, minus. Okay, so f prime times g minus f times g prime over g squared. Okay, so I'm going to give you guys a lot of practice problems to practice this rule, but eventually you will just know it really, really well. Okay, thank you for watching.